So, welcome to Introduction to Engineering, or Introduction to Robotics. This is theoretically lecture number 6. And today we're going to have mostly presentations from people. The other things I'm going to cover today, I'm going to look at wheel calculations. Then we're going to do a little bit of exam prep. Well, actually I covered that. So, and then we'll have lab time if there's anything left at the end. So, hit it. There we go. Let me get to my seat so I can start the time. And again, make sure to talk loudly because the microphone is on this, and I want everybody to be heard.
All right. As you all know, I did the oldest robot called Electro, the Moto Man of the Future. It was built by the Westinghouse Corporation in 1937, and it was showcased at the New York World's Fair from 1938 to 1940. Its features were the ability to walk, talk, smoke, and blow up balloons. Even though it was a wondrous robot that everybody got a kick out of, it was only really used as a promotional tool by Westinghouse to sell their other appliances like lamps, fridges, or other small stuff like atom smashers. But specs, 7 feet tall, 265 pounds, hollow aluminum frame. It was voice activated, so the operator would talk into a microphone, and it would sense the patterns that the operator spoke, and it would record a store response on a record player inside of the robot. It had photoelectric tubes for eyes, which could distinguish between red and green, and in the back of its throat, it had bellows, which would help it smoke and blow balloons. So all this stuff wasn't run on transistors because transistors were invented in like 1950 or 1940 or something like that. So here's a video.
You have to give it time.
I'll take this once after this. He's going to explain how he works.
Turn up the volume. On the podium.
There.
Brain are 48 electrical relays. It works just like a telephone switchboard. If I get a wrong number, I can always blame the operator. And by the way, I see a lot of good numbers out in our audience today.
And that is Electro.
And I should add, do you know how it was powered?
Batteries? Wall outlet?
You don't know?
No.
Okay.
Car battery?
All right, and you need to hit the next key so that we know who's next. Oh.
Alright, so I did the DARPA Grand Challenge Stanley. Basically, DARPA Grand Challenge, DARPA means Defense Advanced Research Projects Agency, and they had a Grand Challenge race in 2004 and 2005. The first one for $1 million and the second one for $2 million. That basically run a course in the Mojave Desert, and Stanley is the winner of one of them. But I'm just going to give us some brief stuff because somebody else is also doing this. Basically, it had diesel-powered, four-wheel drive, electric steering control, powered by a DC motor, custom roof rack, which they put all their sensors on. The total sensors are down here. They had an environmental sensing group, business sensing group, They had 5, 6 laser rangefinders that would tell distances and things like that, a color camera. And then they also have GPS for navigation and things like that. The computer system, they used 6 Pentium computers. A neat breakdown for the computers is that they only used 3 out of the 6 computers. A 4th one was used only to log race data, and the 2 other computers were there just sitting idle. One of the 3 computers that they did have running only did video processing, that was its only job, and the other 2 were used for software and that kind of thing. And then this is their pipeline, which is kind of cool. It just shows the 6 different steps that these are 4 main steps they use in parallel to kind of like get the processing going. So the first one's the interface, and then perception, and user interfaces like the on-screen board, they had to turn it on and off. And should be a picture. That's the back with all the computers in it, and that's what it looks like. Thank you very much.
Question for you.
Yeah,
Is this the DARPA Grand Challenge or the DARPA Urban Grand Challenge?
just said Grand.
Okay. Because it had a lot of LiDARs on it, and that's typically what they used in the Urban Grand Challenge, because that was the one that worked on streets and you needed to have LiDAR on all sides of you.
The course here was mainly just a dirt gravel road, and it also had a winding mountainous road too, so that's probably why they're used.
All right.
Alright, so I did the Awesome Moto robot that's built by Honda. It was one of the robots that's found in our book, and I thought it was pretty interesting because it's pretty much like a humanoid. It can do almost everything that we can do. It can avoid objects that are walking at it. Like if you're walking towards it and it's walking towards you, it'll navigate away from you or around you. It can walk upstairs, as you can see in the first picture, or across uneven terrain. So that's pretty interesting. And it also has voice recognition, so you can tell it to go do something, like some type of task, like bring you a cup of water, and it would know where that is in the building and go retrieve that and bring it back to you. It had people-like extremities, obviously, as you can see, 2 legs and 2 arms, and it can also hop and jump like a person, which I thought was really interesting. And there's a picture in the bottom of it playing soccer, and then the other picture is it like filling up a drink for somebody. So that's awesome.
Well, don't go yet.
Oh.
So here's the questions. I got to ask questions on these. What's the backpack does it have? Is that where it keeps its clothes and lunch, or what?
I think that's where the battery is.
And can you tell me any other inputs and outputs that device has?
Other inputs and outputs?
Yes. He says voice recognition, but does it play voice?
It can talk back to you and it understands your voice. So
Okay.
like it adapts to you if you use it all the time. It'll recognize your voice as opposed to somebody else's.
All right.
Awesome.
Alright, so I'm going to talk about Robot Ostrich today. And that's the prototype right there, Robot Ostrich. This robot's name is actually called Fast Runner. And Robot Ostrich is a bipedal robot which was developed at IHMC. Fast Runner is very fast, extremely efficient, and be able to maintain a high speed while being self-stabilizing. Alright, but this project is under development, and this robot is aiming to achieve 20, 30, or even 50 miles per hour, which is really fast, and it can recover itself from like disturbance from the ground, and it's very lightweight. You see how that leg right there? There's no motor on it. I mean, there's one motor leg, so it's very, very efficient and very, very light. So,
and it's aiming to transport people from place to places, and it's open loop stable. So that's it.
You can't leave yet.
Okay, I'm not leaving. I'm just sitting here.
How do you make it stable with an open loop?
I mean, it would run and run by itself without human interfering. So it'll keep itself stable while running. Yeah. So that's open loop stable, right?
What's open loop versus closed loop?
I mean, closed loop. It's a closed loop. It's gonna be closed loop. Versus open loop.
This is really important because you're going to need it for the test, right?
I mean, for open loop stable means you're gonna keep running by itself, right? That's open loop stable, and keep yourself stabilized. That's open loop stable.
What does open loop control mean?
So without interfering, it's gonna keep going and going and going, right?
Okay, open loop means without feedback. So that means without sensors.
I mean, so it's still under developing. So it probably be out by 2014 or something. So
It's a new.
the name is Robot Ostrich.
Okay, are you done?
Yeah.
Okay, if you can hit the slide.
I'll see the video. Okay, I'm going to attempt to turn the sound off. Okay. I'm going to let the video play in the background while I talk about it if you're interested in looking at that versus me. Hello everyone, I'm Scott Collins. I went into the Da Vinci robotic surgery system. Basically what it is a doctor controlled, basically like a remote control car, but it's a surgery system where it has 4 arms. Each arm has a tool or an instrument, 3 of which have a scalpel, tweezer-like tool that you can stick inside with very small incisions in people as they're doing surgeries. And each arm has 7 degrees of freedom, so it's more than a human wrist. The doctor sits over here on this side station and he controls the movement of the robot based on the camera that is also on the 4th arm. He gets a 3D vision and can see pretty detailed. I think it's magnified 10x in his view, and his movements can be scaled to anywhere from 1 to 1 up to 1 to 5. So really microscopic movements he can make with his tool. The benefits are big, very, very minimal recovery times due to the incision sizes. It's just 1 to 2 centimeters for each tool to get inside and actually work, and you'll probably see. And it rotates along this basis here, so it's just inside this hole, maneuvering inside based on the degrees of freedom. So it's not completely autonomous. It has actuation by DC motors, which run out pulleys and gears, actually moving all the utensils and the degrees of freedom in the ways that it moves. Some of the drawbacks, very expensive. It's about $1 million to $1.5 million. And these tools, for some crazy reason, can only be used, each little utensil on the end can only be used 10 times. Then it has to be repurchased, which causes it to be very expensive. Then the learning curve with it, it takes anywhere from 6 to 8 months for a doctor to become comfortable with basically playing the game enough to get out and do the surgery. That's it.
All right, well, don't go away. What kind of surgeries is this used for?
There's about 4 or 5 that they're really big on, but prostate removal is a big one. Anything that you really need to have big open incisions to remove portions of your body, for the most part.
I mean, is it used for brain surgery?
No, they didn't mention. Most of it was in the abdomen area.
All right, that's all I have. Any other questions?
I think since the precision is, I think is the key. So what kind of sensor does the robot have?
What kind of sensors?
Yeah.
It has, I believe it has touch sensors. It can measure force applied when pulling like sutures. It does suturing and all that, and it translates some of that to the controls in his hands. That's something they're still developing to get a little more accurate. That's the only another drawback to it, that he can't really tell how much force he's putting versus having his hands inside doing it.
I actually had the opportunity to use this Da Vinci.
It's neat.
It was awesome. It's amazing the precision with your hands. You move it just a little bit, and it'll move exactly what you move.
It has a filtration system which filters out the tremors in your hand and all that too, so it doesn't.
Yeah.
Did the patient survive?
Yeah.
No?
We had to like tie these bands around, like you have to tie knots with rubber bands with it, and it's so hard. And like the surgeons, you see the video of the surgeons, and they just touch them, and they tie the knot.
Yeah, they showed his
It took
skin in
me
a
like
grape.
5 minutes to tie it.
They showed his skin in a grape, and it was just, I mean, it was precision.
Didn't they develop that at ECU?
Yeah, they did. My dad actually works with Dr. Chitwood,
Yeah.
which is the guy that started that.
Yeah.
Yeah.
So this is based out of North Carolina, ECU?
Yeah.
Well,
But the company is out of California
Yeah.
that owns the rights to it.
Right.
Hi, my name is Eric De Los Santos, and my robot is Sonic Creo. It was created in 2003 by Sonic. The robot has 38 motors, several motors, and joints, and it has 10 dedicated for the fingers in his hand, and each finger is independently from each other. It has a 12 volts battery, lithium pack on the back for power, and it's it has 1 hour of lifetime.
1 hour.
Up to 23 centimeters per second, and he won a Guinness record in 2005 for being the first robot, the first and fastest bipedal robot. He has 2 cameras that can measure the distance on which the objects are from it. It's also color. They're color cameras. He has 7 microphones embedded in his head, which allows to detect where the sound's coming from and with precision. He has 3 accelerometers, one in the torso, 2 in the feet, so he can auto balance, and it's able to withstand some of the, like example, if you push it, it will auto balance itself and not fall. For control and communication, it has 1 speaker, so he can talk back to you. It will learn speech by interacting with the user. It has 3 microprocessors, 1 for speech and recognition, 1 for visual, and 1 for motion. Each of those microprocessors has a 64 megabytes memory. That's all.
Do you know how tall it is?
It's 2 feet tall, 7.3 kilograms.
Okay. Okay, that makes 23 centimeters per second a lot more impressive.
Yeah, question?
My name is Newton. As Dr. Carter mentioned during the first week of the class, most of the robotic applications are in the manufacturing facilities to increase efficiency, speed, or precision. And the robotic application that I present today is the one I worked on before. The robot is not a mobile equipment at all. However, it meets all the criteria that we define for something to be a robot. For example, it has a power source, so it has a power from the control panel somewhere. It has a hydraulic pump to control the linear low motions. It has the controller, which is the Allen Valley PLC. It's take the inputs from the sensors and process it and output the command. And these are the main steps in the operation sequence of the saw. And the purpose of it is to cut the long pipe into smaller pieces with a precision plus minus 5,000 of an inch. And it is autonomous because once the operator knows what length he wants to cut the pipe, he just set the length, hit start, and then it will run continuously until the pipe run out. That's all I have.
All right. Any questions? By the way, I think this is the only manufacturing robot that anybody talked about. Everybody wants the cool stuff that moves, right?
Useless cars.
Useless cars and things like that. Yeah. All right. If you could advance.
This one is called Strider. You can see we developed at the robotics lab in Virginia Tech. It was a demonstration for locomotion, basically. It served no other purpose other than demonstrate the apparatus that they built. The reason I chose it, I found the mechanical system really, really cool. It's kind of like a Swiss watch. I'm not exactly sure how this works, but you have like a rotational gear here and actuators on each leg. It's got 3 points of contact. So as we discussed, that's all you need for stability. So I'm going to try to play this video. Any way I can copy and paste this?
You have to get out of there. You have to. Keep on down. Copy the link.
Oh, you got to turn it back up on the console there.
Have you seen anything in nature of that? Before that, so you know H.G. Wells' War of the Worlds novel, a movie, and what you see over here is a very popular video game. And these fiction, they describe these alien creatures and robots that have 3 legs that terrorize the Earth. But my robot Strider does not move like this. So this is an actual dynamic simulation animation. It's going to show you how the robot works. It flips its body 180 degrees. It swings its legs between the 2 legs and catches the fall. So that's how it walks. But when you look at us human beings, bipedal walking, what you're doing is you're not really using a muscle to lift your leg and walk like a robot, right? What you're doing is you really swing your leg and catch the ball. Stand up again, swing your leg and catch the ball. You're using your built-in dynamics, the physics of your body, just like a pendulum. We call that the concept of passive dynamic locomotion. What you're doing is, when you stand up, potential energy to kinetic energy. And applying the principles of walking to this robot. Thus, it's a biologically. It absorbs the shock and starts walking. What you see over here, this yellow thing, this is not a death ray. This is just to show you that you have cameras and different type of sensors. Because it is tall, it's 1.8 meters tall, you can see over obstacles and bushes and those kind of things. So we have 2 prototypes. The first version in the back, that's Strider 1. The one in the front, the smaller, is Strider 2. The problem that we had with Strider 1 is it was just too heavy in the body. We had so many motors, aligning the joints and those kind of things. So we decided to synthesize a mechanical mechanism so we can get rid of all the motors, and with a single motor, we can coordinate all the motions. It's a mechanical solution to our problems with mechatronics. So with this, now the top body is lightened up, so it's walking in our lab. This was a very first successful step. It's still not perfected. Its copy falls down, so we still have a lot of work to do. The second robot I want to talk about is called Impasse.
Okay, so yeah, if you're interested, that guy has like every robot in his lab is like not something you've never seen before. So it'd be good to go check out if you're interested.
Facebook. Your Facebook.
F5. No, you shift F5. There you go. Any questions?
My name is Herbert Hill, and this is my presentation on Ranger, the walking robot. It was developed in Cornell University, and the main purpose of it was to be in competition for the fastest bipedal robot. This one was unique because it was kneeless, so there was no bending between the hip and the ankle. In the picture I have the picture of the hardware, the motors, and there's only a motor in the hip, and then there are two in the ankle, so that's where most of the torque actually is. And to give feedback, there were potentiometers put both in the hip and the ankle, so that way it would measure the amount of voltage, so it would know when to change position. This project started in 2005, and it has still gone on until 2011. If you look at the times and steps that it has increased tremendously. It started out with only 39 steps and only walked for 26.5 seconds, and now it has taken 186,076 steps and 30.81 hours. And I have a video also.
You can just click it.
It was already open, so.
And it's also controlled. It's controlled remotely by a user, so it's not, in my opinion, it's not completely autonomous. But in the walking motion, it does by itself. But as far as going left or right, someone has to follow the control. It started out being tethered, and then it eventually was wireless. And you'll see a little bit in the video where there's a person actually following it the whole time. And then also participating in Relay for Life. So you can see the person.
I like the hat.
So that is the Ranger Walker. Are there any questions?
Why does he stop walking? I mean, his battery dies?
Yeah, they basically just run him until he can't run anymore, or the competition ends when he's no longer able to stand up straight. Like before, the times were so short because he would like tip over and stuff like that. So this robot was actually in competition with Boston Dynamics as far as the fastest walking robot. And like every time they thought they set a record, Boston Dynamics would basically beat it. So they kept going back and forth. So, I just thought it was funny. I saw it in the book.
So one thing I should point out to everybody here, imagine this is one faculty member's research project he's done for up there 6, 7, 8, probably even longer than that, 10 years. That's his whole life. One robot like that. And the thing is, how useful is that?
No.
I mean, there's all sorts of technologies that people learn associated with something like that.
Made a cool YouTube video.
Cool YouTube video. The fact that they're also trying to look at how do you minimize the amount of energy needed to run it, like the motors to be able to make it walk, so that it could really go more than 31 hours on one battery charge.
Yeah, at the end of Fallman used a equivalent battery to a laptop battery. So that's what they ended up with. But they had there are a ton of reports and stuff for each time, and there were a lot of people who worked on it.
All right. Thank you. Mr. Hunter.
Is that the real one or the human?
I decided to talk today about the LS3, which is also known as the Alpha Dog, and it's another DARPA-sponsored project, and it's kind of the next generation up from the Big Dog that we saw a couple of classes ago. So it's basically designed to follow a soldier anywhere that they can go, through any terrain that they can go through, and it's comparable to the Big Dog in that it can carry more weight, can travel longer, and can travel for a longer amount of time. They're also looking into making it as a mobile power source to hook up radio batteries and charge those for soldiers as it's going along. But the reason I wanted to talk about it was I found that the way it follows is really cool. There's 3 settings. The leader-follower type is he gets as close as he can to the leader that he's following and takes the exact same path that person takes. Whereas there's leader-follower corridor, where he hangs back a little bit and he'll look around at the environment around him, and based on the objects in his way, he'll make his own route but stay relatively close. And then there's also the go to waypoint, which he uses a GPS to make his own route and just get there on his own. So the inputs used are, they have a LiDAR for the navigation, route planning stuff. They have cameras that he uses to follow the leader. There's a GPS for the go to waypoint setting. There's a gyro to help keep it stable, and there's actually a video on YouTube where this guy takes all of his force and just pushes as hard as he can, and it stays stable the whole time, gets right back on path. And they're looking at adding in a microphone so that you can yell out commands to it and make it interactive with the person that it's following. There's a couple I left off just because I ran out of space, but there's also direction and force sensors inside the legs, and there are temperature and pressure sensors inside the motor. Are there any questions?
Is it bulletproof?
Probably not. They don't have a whole bunch of stuff on, so you'll be shooting like soldiers' gear. So, kind of.
Hopefully.
Was there any comparison as far as speed? I know it's not a critical factor, but did they mention that?
It was listed online. They said it could run, I think it was around 22 miles an hour. Again, there's a YouTube video out there where they have it in a factory just running full speed, and it's pretty fast.
How long is that thing?
It's probably a little shorter from this side of the table, maybe to here.
Yeah.
It comes up to this high. It's big.
Because the top almost like resembles like a stretcher almost. So
yeah, it's big. It's got to carry 400 pounds worth of stuff, so it's a pretty big machine.
How loud is it?
It's pretty loud.
So it still has the compressor.
They're working on making it quieter so that you can actually take it on covert missions if you need to. But I assume for now they just say turn it off and leave it if you need that. It's actually powered by a go-kart motor.
Does it have a self-destruct button?
Not yet.
Go there and sport.
Oh, they also mentioned using the camera to, when they take the pictures, try and upload them and gather intel about where you are based on that thing's cameras.
Yeah.
Any other questions?
Sure. Let's fight though.
Sweet.
You.
Cheater.
Cheater.
An internal product.
So I'm presenting the Pegasus robot, which is a Westinghouse company model, and it's designed for inspection to do maintenance in a steam generator in a nuclear power plant. So typically in a PWR, a pressure water reactor power plant, you have the primary system, which runs to the core of the reactor, and then that goes to the steam generator, and then it generates steam, and then that goes to the turbine, and then it goes to the generator. So the steam generator has tubes for the primary and the secondary systems, and it's considered a high radiation area. So typically a robot is done to perform maintenance instead of humans to minimize the safety. So the packages is used on these, what's called at the bottom of the steam generator is called a tube sheet. And what it does is it latches on it, and by sensing and grips, it runs the tube to do inspection for leaks and breaks in the tubes.
What are the motors and sensors that it uses?
I wasn't able to get information about the sensors. I know it has touch sensors, and I know it has a camera, but I wasn't able to get a lot of information about it.
They want people to copy.
Secret.
Secret.
Any other questions? All right, being none, let's take a 5-minute break and we'll get back. Hit it.
Hi, my name is Raju. I'll be speaking about ball bots. Now these robots as such, they stand tall and are capable of balancing on a ball. There are wheels that are in contact with the ball, which are used to control the rotation of the ball. Now the basic concept on which it works is an inverse of the mouse ball. The older generation mouse that we had, they had the ball at the center. So as you move the mouse around, the ball rotates, the wheels rotate, and that is decoded in order to determine where the pointer is supposed to move. Well, this is the inverse of that. So then based on where the robot needs to move, the wheels rotate and the ball rotates to take you into that particular direction. Now as you see here, this is the robot, and when it needs to move from point A to point B, initially what happens is the ball rotates in the opposite direction so that the robot tilts in the direction of where it needs to proceed, and then it moves in the other direction so that the robot slowly tilts like this, and as it reaches the destination, it becomes stable and stands straight. This is a video that you can see. You can see here, initially during takeoff, the tripods, there are tripods over there in order to keep it stable when it is not being used. They take off, and the ball bot can then move around. Still remains stable.
Abuse.
Any questions?
None? All right, thank you. Next.
Oh, I have a question.
Yeah.
Do you know what plans they have for using that robot?
Well, actually, I'd seen a similar robot in Star Wars.
Oh, and we know that's real life. Yeah.
In the second one, Attack of the Clones, Obi-Wan Kenobi goes to figure out where those particular bullets are from. He meets his friend with 6 hands. So the waitress over there is one of these robots carrying drinks around. So maybe that.
Here we go.
Get your waitresses.
Alright,
I'm Jessica Meeks. I'm going to go over a UNC Charlotte project actually for a pipe traversing robot. This pipe traversing robot is designed to clean out and traverse through dryer ventilation systems, basically your household dryers doing laundry and all that. And what you usually do pipe traversing robots for is more detection and inspection of like industrial sized piping or commercial HVAC systems, which can be seen in the designs over there. And the thing about all these designs is they're very large, they're very bulky, and they're usually one section and very, just it does this. The pipe traversing robot we've been working on, because the dryer ventilation system, if you think about it, it's very small, it's 4 inches in diameter, and it's made up of everything. You've got really flexible, puncturable material, as well as very rigid, slick material that you can slide down. So in order to come up with a design to compensate for both of these materials, we came up with this airbag inchworm design. And basically, the airbag inchworm does is it has 2 anchor ends. So you can see in our several designs, we each have 2 chassis on each end. One chassis would inflate this airbag, basically, while the linear motion device in the center, which is a screw device I'll show you a video of in a second, it'll extend out, and then the other chassis will inflate, and the back chassis will deflate and will contract, and so it inches through the system. We've gone through several designs with different kinds of pressure, and the basic end design that we're at right now is a pump system, which is a closed-end pump system, and it'll basically alternate the air in between. And this design also allows us to go into like smaller, possibly plumbing, where there's a lot of water and everything. So all we need to do is encase the electrical system, which will be made up of basically a microprocessor for the controls of the motor, as well as like an accelerometer and gyroscope, because there's like 90 to 180 degree turns in there that we need to shorten the extension time for in order to make up for that and make sure we're not putting too much pressure and puncturing those areas we talked about before.
Control and click.
It starts off really slow, because this was basically our first beta test, and we've seen screw linear motion device like this before when we were talking about linear actuators. And so basically here's an original design that we did for this specific robot. But yeah, that's about it for how it moves, where it goes. Any questions?
Shift F5.
Was this your project?
Yes.
How does it detect cracks inside a pipe?
This doesn't actually detect the cracks. This one is based around cleaning the pipe. So what it will do is it will traverse all the way through, and then you attach a brush device and you pull it back through, and so it cleans out the dryer lint, because the lint will ignite at times and it will cause house fires and cause a lot of damage.
Mr. Morgan,
Yes.
the word I heard most frequently when I showed this to people was, "Isn't that cute?"
That's good. The robot I chose to do was the iRobot Roomba. Most of you guys are probably familiar with this one. What it is basically an automated vacuum cleaner that uses an algorithm designed by MIT to transverse through your whatever room it is in your house and clean it at the most clean way possible. It actually goes over almost the entire room multiple times to make sure that it's able to clean every little spot. And the algorithm was designed by MIT based on the studies they did while studying animals hunting for food, and how they basically checked across an area of land looking for whatever food they were trying to find, and how they covered the entire area. And as far as features that the Roomba has, it has a dirt detect
It follows walls. It has cliff detection. It has light and soft touch bumpers. It has an escape behavior in case it gets trapped in, say, under a table that doesn't have a clear way through. And it also has an anti-tangle technology in case it's going up over a carpet or it starts to drive over cords or cables or anything. And some of the sensors that it uses bump sensors for both of the touch abilities. Ultrasonic sensor is for the cliff detection. It has the infrared sensor in case you set up a lighthouse. It's called a lighthouse, and what it does is basically creates a virtual wall to I guess make the path of the room smaller in case you don't want to clean an entire room. It has wall and object sensors, which are used to follow the wall as well as avoid running into the walls too hard. And the pattern, the algorithm, it basically starts in a spiral pattern until it finds a wall, and then it follows that wall until it sees an object and goes around that object and continues to clean the entire outside of the room first, and then it works on cleaning the middle of it. Any questions?
Does the cat come with the kit?
I do not think so. I think the cat is extra. Yeah.
Oh, thank you.
But it's so cute.
Get serious.
All right, next.
I'm Alex Monster. I did the sand flea, or jumping robots. The sand flea is a semi-autonomous robot that can jump extremely high heights up to 30 feet in the air. It can, while it's jumping, it's very accurate at jumping and is very stable while in mid-flight, so that it's able to use a camera to be able to get visual of where it's jumping to, so it can send that wall in the air back to the one controlling it. The way it jumps is using a CO2 piston, so it can get this extreme height. It only weighs 11 pounds. It has an internal stabilization system as well.
No.
Oh my! You can see there how level it is while it's in mid-flight.
It's awesome.
So much better.
Jump down, jump back down.
Okay.
Jump.
Nice.
Catapult.
You can see just how level it is while falling. So it has a very stable system. They plan to use it over in Afghanistan to jump over walls to be able to see what's on the other side.
And
then
attack
the monsters.
Did they say how they like reinforce the electronics inside so it didn't destroy itself?
I couldn't find anything really in regards to how it's actually control what's inside it and do all that. I was lucky enough, I think, to find the how it's going to be able to the way it jumps.
Is it remote controlled?
I couldn't find out.
All right, next. It's not as if we've seen this before, huh?
Yeah.
Deja vu.
Deja vu. Stanley.
Alright, so as you guys know, Stanley's already done today. Which is okay. I'm not going to drown you in the same information. I'm going to try to talk about some other things so everybody doesn't go to sleep. Something like that. But let's just start off talking about the challenge that they had in front of the Stanford racing team when they started designing Stanley. The original DARPA challenge of 2005 was in the Mojave Desert in California. It had it was a 150-mile route, and it took it took the Stanley 6 hours and 54 minutes to complete, but this was during, it had, the actual terrain had from anywhere from desert plains to mountainous terrain, and even some roads that had steep cliffs right like a couple feet off of the main path. So this was something really challenging. Not many robots, were able to complete it at all, let alone 6 hours and 54 minutes. But there was a major motivation for the Stanford people to create this robot. There was a $2 million prize if you win the competition. So, they ended up winning, and that was a pretty amazing feat just because it surpassed all the other performances of everybody else that competed. But it was used to they picked the body of the Volkswagen Touareg, and they did that because it had a lot of the extensive integrated computer systems that allowed them to throw out a lot of the sensors and actuators that if they just used this, a different car, they would have to actually add. So a lot was actually done within the computer system that was already wired into the car. The steering and the gear shift was an actual mechanical actuator. A piston actually controlled the gear shifting, which is pretty cool. And an actual motor steered the car by changing the direction of the steering wheel. And then on top, it had the LiDAR sensors, the light detecting and ranging sensors. They were mounted on the top. There you can see in the picture, right on top of the rack. Those were used to create a 3D map of the surroundings. And then it went to a couple of the computers that were sitting in the back, a couple of the 6 computers that were sitting in the back running Linux, in which had a very extensive computer program that was written on them. And that computer program analyzed the 3D information coming from the LiDAR sensors in order to sense any objects within 40 meters and to plan an actual route around them. And you have to the average speed I calculated was 21 miles per an hour through the whole course. So I think it's pretty impressive. That's about it.
Any questions?
Next slide.
Next slide.
This is Robbie the robot. He's a robotic operating buddy. I never had the privilege of owning one, but I did have the privilege of playing with one. It was an accessory for the Nintendo Entertainment System, released in July 1985. It was, marketed as a family computer robot. The robotic, or I'm just going to call him Rob, the robotic operating buddy, receives up to 6 commands via optical flashes that were emitted from a television. It worked in conjunction with a cathode ray tube, with an old TV. And that's what gave it its commands. Certain colors that emitted on the television screen, like it gave it commands of what functions it needed to do. Some specifications: it operated on 4 AA batteries. Its height was about 9.5 by 6 inches wide. Its head can actually tilt 45 degrees up and down. Its arm movement was a full 240 degrees. The shoulders actually move, and it had 5 stopping points. The hands wouldn't open, like it's almost like a claw, basically. there was 2 games developed, Gyromite and Stack Up. Both came with certain accessories that were, relative to each game. I'm going to show you a video here of Robbie in action.
You should be able to just click on it.
Oh, yeah, okay.
Except that's not yours.
Why does it do that? Notice that. Yeah.
Put a full screen and then just click it.
Control, click.
Why don't you?
You didn't get the whole thing.
Yeah, you missed H
Really?
at the beginning. So just type H.
This text
He's gonna drive it.
HTTP.
He'll probably take it as just an H.
Yeah.
Alright, so good stuff. Volume on.
Oh yeah, I hit mute volume. So
Be careful. The volume will be very loud.
I don't think there's anything going on.
Bond, and this is.
Oh, it's that small?
Yeah.
Oh, wow.
It says 9.5 inches.
Mario
So
Luigi
just
Ultimate
play
style
gyro.
nonlinear digital editing.
So you can see, it's hard to see, but you can actually see the flashes, the 3D. Like,
We can't hear you.
the robot.
We can't hear you.
Oh, I'm sorry. That would just drive me nuts. I don't care if it's 1985.
Back in the day it was cool, but being older and looking back,
I'm thinking, okay.
games are very dull and boring.
What are you talking about? Mario was cool.
All right, we get the point.
So both the games came with the little paddles to push the A and the B buttons on the Nintendo controller. And Stack Up, obviously the robot would stack blocks on top of the paddle to depress the buttons. So this one had gyros. And that's Robbie. That's Robbie the robot. What is it, Shift F5?
Shift F5, yeah.
All right, good afternoon. My name is Benjamin Rhodes. I'm going to talk for a few minutes about Robo Nova, developed by High-Tech Robotics. As you can see from the picture, it actually utilizes servo motors, 16 of them. Robo Nova 1, and essentially there's Robo Nova 1 and Robo Nova 2. Say that 5 times fast. But it was developed in 2008, of course, by High-Tech. Again, using 16 digital servo motors. It actually is programmed with an Atmega 128, which is pretty common, especially in the ECE department and the EP department. We use that microprogrammer to death. I mean, we definitely use it to death. The great thing about this was it was used to develop as a developmental platform. So this can be programmed with a high-level language such as the Lego kits that we use, all the way down to an assembly language programming. So it's made for a wide variety of uses and programmers to get them used to this many degrees of freedom, which is 16. It also can be expanded to have many peripherals such as sonar, light, gyro, and sound sensors. Many videos that I found actually develop their own different claws and different apparatuses to use with the extra additions. Since it has 40 ports on that Mega 128, it can include up to 24 servo motors. So it includes 16 servo motors, so it can be expanded to 24. So your mind can go, your imagination can really go if you want to figure out what uses you can use for this robot. So it also is pretty expensive. If you like this robot, you can buy it for 48 payments of $19.99. So I got a quick. As we mentioned in class, each degree of freedom comes with a cost. So have 16 degrees of freedom, you're going to have very expensive. So as this is loading, although you can perform life operations with 7 degrees of freedom, what can you do with 16 degrees of freedom? You actually can write your name. So this robot named Thor was programmed to actually write his name with a pen. You can see the varying degrees of freedom here. At the very end, he's very happy. He shakes his head because he's so happy they wrote his name. And he underlines it because it's very, very important. So
He needs work on his skills, huh?
he does. He's currently at a first grade level. They're working on a more advanced level at this point. But that's pretty much Robo Nova. Any questions?
Line paper.
All right, next. Soccer boys.
Alright, I'm going to talk about Now Robot. The Now Robot was designed and built by Robotics. It took him about 10 to 15 years to do research and get all this robot together. It uses a computer that is powered by a 1.6 gigahertz Intel Atom processor. Sensors, it has 2 HD cameras, one over here on the forehead, the other one on the mouth. It has 4 microphones to detect locations of sounds. 2 right here in this area and then 2 on the sides. 2 speakers right here on the side. It has a tactile sensor on the top, on the crown. It has 4 sonar sensors for distance, right here on the chest. And it can be 21 or 25 degrees of freedom. For instance, the one that has 21 degrees of freedom is used for the soccer RoboCop, because they don't need degrees of freedom in the hands, because you don't play soccer with the hands. The battery, it lasts 1.5 hours or more, depending on how much the robot interacts with the environment. Connectivity, it can be connected using the internet or Wi-Fi. It can communicate with other Now robots, transfer data or like knowledge that it acquires. Other features, it can work like a human in a direct line. It has a whole body motion. It has a fall manager system, meaning that when it's falling, it can put the hands on front so it doesn't damage his face, and also can get out. It has object, face, and sound recognition, meaning that if you have an object like this book, you can teach him that it's a book and what kind of book it is. And next time the Now robot sees the book, he will know what it is. Same with the face and same with the sounds. It can speak up to 9 languages, and the price is about $16,000. If you buy 3 or more, I think you can get like $500. And that's Now robot. Which
Any questions? All right, next.
Who do we have to go to get the discount?
3 or more.
Win the lottery. Next.
This is too cheap.
This is Sapphire, which is a shipboard firefighting robot. It is designed to be able to navigate through the passageways of ships to extinguish fires, as well as do other missions that it can be assigned to. Some of the sensors and inputs that it uses is a regular camera for object detection, object avoidance, maybe to find people if they're lost or need help getting out. Gas sensors, because when a fire burns, you have high levels of carbon dioxide and low levels of oxygen. And as well as the IR camera, which enables it to see objects through smoke and in low light situations. To extinguish the fire, it uses what's called a peak grenade, which is similar to a dry chemical extinguisher that pretty much blows up and distributes the dry chemical agent throughout the fire. It is also designed to work as part of a team, so that if others are around it, they can give it voice commands as well as hand gestures to tell it what to do, as far as which room to go into, to search through, and other commands that they might need to give it. And it is also being developed by the Navy Research Laboratory, and it's based off the MIT
humanoid.
What kind of motors, motion devices does it have?
The actual platform came from MIT, and they've implemented their own software and algorithms into that.
I mean, motors. What kind of motors does it have? You don't know?
No, they
Okay.
provide that information.
All
Are
right.
they actually using this yet in the boat?
No, it's still in development right now.
All right, next.
Oh, shit.
It is a Russian flag.
Actually, this guy is Russian. This is the chess Terminator. It's a multi-axis robotic arm connected to a computer. As you can see down here, it is also connected to the chessboard, and it uses sensors in each of the chess pieces and the board to detect where all the pieces are, and then it's designed to whoop whoever it plays. And, no, very, very seriously, they have to play something called blitz chess, because if the computer is given more than a couple seconds to think, it will completely dominate human players. Yeah, so it was built in this. I think this competition was in 2010, and this is Vladimir Kramnik, and he was the then world champion. And previous to that, there were a lot of robotic chess players, but they didn't actually move the pieces. They just did all the math or like calculations and tactics and everything, and figured out where the pieces needed to move, but they had actual people moving them and pressing the timers. So I've got a video of this thing in action.
Your video doesn't.
Yeah.
Dude,
Look at that one.
Oh, no video. Just photo.
So picture.
Eugene.
Minus 2 points.
Okay. Well, in the video, Vladimir Kramnik, he's playing this. It's a little over 2 minutes in, and he's clearly going to lose, and he forces it into a draw. So, like, if he made a wrong move, which he's not going to do because he's a chess master, the computer would still have a chance to win. But he clearly knew it was going to be a draw. He holds his hand out to try to, declare a draw, and the computer the robot swats it to the side, and then continues playing.
Next.
I'm John, and I chose the water running robot. Obviously, from the name, it can run on top of the water. It's modeled after a lizard. As you know, some lizards can run across water, not all, but some. It's 1.5 meters per second, which is getting it. It uses body mass, length, speed, and shape of foot are the factors that go into it actually being able to run on the water. It's only about 3 or 4 inches long, and it's teeny. It's nanorobotics, and it actually was a design from Carnegie Mellon University and their nanorobotics team or whatever. And it actually does run on water, and it just has one motor in it that makes it slap the water and push forward, and that's about it.
You gotta find
So,
the
so it runs on water. It can't like stop and stand still in the water.
No, it doesn't have floats or anything on it.
float in the bottom?
No.
Do you have
no.
video?
It just, and it's not autonomous. You turn it on and then put it in the water and it just starts going. So it's not autonomous.
Does it have any sensors?
No, it actually doesn't.
It's open loop.
It's they're working on it right now to make it to where it can turn in water. So like as it's running, it'll turn, and also to sense things to get around them. But as of right now, it's just the motor. They just figured out how to force it to run on water. Any questions?
All right, thank you very much.
Wow.